Hey everybody, this is Mrs. Brorman. I was just coming to you from our classroom. I came in today, thought maybe I would set up our lesson on fractions here in the classroom. Seems very lonely here without you guys. I'm really hoping that we'll be able to see each other next year when you're fifth graders. So anyway, I'm going to go ahead and get started with our lesson. So I know you guys are anxious probably to get moving with that. But today we're going to be looking at comparing fractions. And I first of all want to show you that I had sent home this paper right here for you guys. Been weeks ago, like probably 8 weeks ago when we first started doing fractions. I gave you guys, this paper has definitions and examples, and we're going to be looking at comparing fractions. If you have your math binder and you have this paper, it would be really good for you to find that and just kind of keep it handy over the next several weeks. We are going to be doing fractions for the next 3 weeks, and most likely we'll be doing them all week, every week for the next 3 weeks. I know we have 4 weeks of school left, but my goal is for us to get through this in 3 weeks, so we'll be finished that last week and won't have to do any math. So my goal was for us to be working on fractions when we came back to school, and since that's not going to happen, we're going to do that now. And fractions is a huge part of your 5th grade year, so it's going to be really important for you guys to really pay attention and understand this information. And if anytime you have questions about this, shoot me an email, or if you need me to give you a call, I'll be happy to do that. So I'm going to post this video, obviously, and then I'm also going to post some other videos off of YouTube about the different topics. Now, keep in mind that when you watch those YouTube videos, they might include information that we don't necessarily cover in 4th grade. So I'll kind of want you to, on the videos that I post this time, just look at how they do either pictorial representations of fractions, number lines, or cross multiplication. So I would like for you to kind of focus on that. Anything else they teach you as far as finding like denominators, or if they teach you how to do decimal form, then that is probably going to be a 5th grade skill, which we'll talk about it a little bit, and I'll kind of show you what they're doing, but really we don't need to focus on that at this point. So here's what we're going to be doing. We're going to do different ways on comparing fractions. Number one, we'll look at a picture representation of comparing fractions. Then we'll take a look at number lines. And then before we start doing cross multiplication, we're just going to look at if the fractions have the same denominator, or look at if they have the same numerator. And then finally, we're going to kind of wrap it up there with cross multiplication. You learned cross multiplication in 3rd grade, so it's going to be easy for you, I believe, and then we do it in 4th grade. Now, finding a common denominator, that happens in 5th grade. I might take a minute and show you how to do that, because it's really about equivalent fractions. And then finding an equivalent or an equal decimal, that's above 5th grade. And they might show you how to do that in 5th grade too, but that's a little bit above. So some of the videos do contain those last two ways to find and compare fractions, so just kind of keep that in mind. So we're going to start today working on picture representations of fractions. Now, I know this might get a little crazy. I'm trying to do this by myself, and I hold my phone. So first of all, we're going to take a look at this worksheet here. I think the best thing for us to do is just kind of look at some pictures of different fractions, and this says that they want us to shade the model to show the fractions, then compare the fractions using, or write a greater than, less than, or equal to complete each statement. Now, what you need to understand is anytime we're comparing something in math, you are going to use the greater than, less than, or equal to sign. I understand that it might seem a little bit crazy because we're doing it with fractions instead of just normal numbers, but when we see these picture representations, I think you'll be able to actually see the comparison. So the first one is a half, and we have, what you also need to make sure you realize is that both of these picture representations are the same size. So when you are comparing two things, they have to be the same size. If one of these was a smaller hole than the other, like let's say it was only that big and you're comparing it to that big, we wouldn't be able to do that correctly. So we have to make sure that the whole picture is the same size. So if we're gonna do 1 out of 2, we're gonna shade in 1 out of the 2. And then on the next one, we're gonna shade in 5 of the 8. So 1, 2, 3, 4, and 5. And when we do the picture representation, you can see that 5/8 is bigger than 1/2. So you're gonna wanna put your less than sign in. So 1/2 is less than 5/8. If we move on to the next one, we have 5/6, and we're gonna compare that to 2/3. So I'm gonna shade in 5 of the 6, and then 2 of the 3. And what you'll see is obviously 5/6 is larger, so we're gonna say 5/6 is greater than 2/3. Our next one is 1/4 and 1/5. And we're gonna talk a little bit more about when you see numbers that are the same on the top or the numbers that are the same on the bottom in just a few minutes, but I'm gonna shade in 1 of my 4 pieces and 1 of my 5 pieces, and we can see that 1/4 is larger than 1/5, so 1/4 is greater than 1/5. I'm gonna kind of park it here for just a second and let you guys take a look at that and see if you can just kind of visualize shading in the 3 and the 6 and see if you can see what maybe that might be. Okay, so if I shade in 3 of my 4 and 6 of my 8, I'm gonna notice that they actually take up the same amount of space. That's because these are equivalent fractions. If I did 3 times 2, I would get 6, and 4 times 2, I would get 8. So that would be an equal fraction. Okay, now we have number 5. We can do 3/4 and 1/2. We can see that 3/4 is larger, so 3/4 is greater than 1/2. Remember that sign needs to open up to your larger number. So 2/4 and 4/8. 2/4. And again, we see that those are also equivalent. And then we have 1/6 and 1/3, if you want to take a second and take a look at that. If I do 1 of my 6 and 1 of my, paper's kind of moving around, 1 of my 3rd, I can see that 1/3 is larger, so 1/6 is less than 1/3. And here I have 1/2 and 2/5, and I can see that 1/2 is larger than 2/5, so I'm going to say 1/2 is greater than 2/5. So basically, guys, when you have pictures, it's real easy to compare the fractions. You just see which picture takes up more space, and also remember your pictures have to be the same size. Now, we're going to go on to looking at number lines now. Put my marker together here. We'll move this like this. I hope that doesn't mess you up any. But when we look at number lines, what I want to do is I want to kind of keep in mind, and I'll talk about it even more later, but when we were here, we talked about how we need to keep in mind we have some benchmarks, and benchmarks are things that don't change. So I have a 0. I know I always have a 0, and I know I can always have half, and I know I can always have 1. So I'm able to kind of figure that out like that. Now those benchmarks are really important, especially when it comes to putting these fractions in order. But right now we're going to compare these two fractions, but we want to use a number line. Now if I use a number line, it's really important that my number line be divided up in equal parts according to the denominator. So my first one is 4/8 and 2/8. So what I want to do, the denominator is 8, so I'm going to divide my number line up into 8 pieces. So I've got 0, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put my constants on there. So there's my 0, here's my 1, And then 4 is half of 8. So 1, 2, 3, 4. This is going to be my 1/2. So what I'm going to do now is I'm going to put these fractions on the number line. So 4/8. 1, 2, 3. Oh, right there. 4. So that's 4/8. And 2/8. I'll go over 1, 2. Put that down here. 2/8. So I can see that 4/8 goes over farther than 2/8. So I know 4/8 is greater than 2/8. The next one is divided up into 6 pieces. So I'm going to do my constants. 0, 1, 2, 3, 4, 5, 6. So I know this is my 1 and this is my half. Now I'm going to put my fractions on. So 5, 6, 1, 2, 3, 4, 5 is here. And 3, 1, 2, 3, 3/6 is right here at the half mark. So I can see that 5/6 is greater than 3/6. And the last one, dividing this up into tenths. So I've got my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my 1. 1, 2, 3, 4, 5 is my half mark. And now I'm going to compare them. So I'm going to go over for 3/10. 1, 2, 3. 3/10. And 7/10. 1, 2, 3, 4, 5, 6, 7. 7/10. I can see that 7/10 is larger. So 3/10 is less than 7/10. And that's how you would put your fractions on a number line, and then you would be able to compare them. All right, we're moving over here to comparing a fraction with the same denominator. Well, if we have, excuse me, if we have a picture, like this example, it says compare the shaded parts of the two figures, we can see that both of these are broken up into 3 parts, so our denominator is going to be the same. But on the first one, we're going to shade in 1, and on the second one, we're going to shade in 2. So 1/3 and 2/3. Of course, this is with a picture representation, so it should be a little bit easier to see what you're doing, but 1/3 is less than 2/3 because you have more shaded on 2/3. But basically what you want to know here is if your denominators are the same, you're really just looking at your numerator at that point and treating it like a regular number. So the bigger number will be the bigger fraction. And that's true when the denominators are the same. When the numerators are the same, it's going to change a little bit. And when the numerators and the denominators are different, you can't necessarily follow that pattern either. So let's take a look at a couple of these. So for number 1 and 2, we're going to write a fraction represented by the shaded parts of each figure, and then we're going to write greater than or less than or equals to on the line. So this one is 1, 2, 3, 4, 5, 6, 7, 8. We know that the denominator is 8. Oh my gosh, I'm sorry. I wasn't even looking in the right spot. And we have 6 shaded pieces. This one also is 1, 2, 3, 4, 5, 6, 7, 8. And this time we have 5 pieces shaded. So because they have the same denominator, we just look at our numerator. 6 is larger, so this is a greater than fraction. This is hard writing with one hand and holding my phone. Okay, so the next one, we're broken up into 6 pieces, both of them. So we're going to have the denominator of 6. This one is 2/6, and this one is 3/6. And guys, since it's kind of hard, I think I'm just going to put the symbol in here. So same denominator, just look at the top number. 3 is larger, so that's going to be 2/6 is less than 3/6. Now, I'm going to kind of pause for a moment, and I'm going to have you maybe use a scrap piece of paper and take a look at these, and maybe you can write down, you know what? These aren't the right ones. I may have them mixed up. Yep, I did. Sorry about that. Here we go. I'm going to have you take a look at these now. I had the wrong paper in the wrong order. Okay, so let's take a look at each of these. These are broken up in the same denominators. Okay, so take a look at number 3. and I'd like for you to write down both fractions. And then noticing that both fractions are denominators are 4. Okay. I then need you to put in your numerator, and you can then compare them. So 3 is greater than 2. Okay, number 4. What is your denominator? 5. And your numerator here is 3, and your numerator here is 4. Since our denominators are the same, just look at your numerator, and 3 is less than 4. Next ones, let's find our denominator. 9. Oh my, it's getting difficult again. Now, how many pieces are shaded on the first one? 5. And on the second one, 5. So since they're both the exact same fraction, they would be equal. And number 6, what would be our denominator? 12. Okay, and this one's numerator is 3, and this one is 4. So that would be 3 is less than 4. Very good. We're going to stop there and move over now to if we have the same numerators. We're going to look at if we have different denominators and we have the same numerator, it's going to be a little bit different. So when fractions have the same numerators, compare the denominators. The fraction with the smaller denominator is actually the larger fraction. Now let's figure out why that might be. If this is broken up into 4 pieces, and this one's broken into 9 pieces, we have larger pieces when we only break it up into 4 versus if we break it up into 9. If you would imagine this to be a pizza or a candy bar or your favorite food, and you have to share it with someone, and we do 2 4s and 2 9s, you know, which one are you going to have? Which one are you going to get more pizza from? You get 2 of the 4 pieces or 2 of the 9 pieces. You're definitely going to get more if you get 2 of 4 pieces versus 2 of 9 pieces. So when your denominator is smaller, your fraction pieces are larger. So it's kind of the opposite. So if you have the same numerator and you have different denominators, then you can look at your denominators and the smaller number would be larger. So let's take a look at this one. This one's broken up into 5 pieces. And this one's broken up into 1, 2, 3, 4, 5, 6, 7, 8, 9. There's broken up in 9 pieces. This has 3 pieces shaded, and this one has 3 pieces shaded. Well, would you rather have 3 out of 5 or 3 out of 9? 3 out of 5 would be larger, so that would be a greater than fraction. Another thing that I kind of think about too is the closer these numbers are together, the bigger the fraction. So 3 is closer to 5 than 3 is closer to 9. There's only 2 numbers difference here versus 6 there. It's just another way to think about it. If we take a look at the next one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is our denominator here, and 8 is our denominator there. 1, 2, 3, 4, 5, 6. Obviously, this is going to be 6 also. So if I have 6 tenths or 6 eighths, my numerators are the same, my denominators are different, my smaller denominator is going to be the larger fraction. Plus, 6 is 4 away from 10, and 6 is only 2 away from 8. So there's a smaller difference between those 2 numbers. So that means I need to put in a less than sign. Here's that paper I tried to show you a minute ago. So we'll do a couple of these and then move on. The next one, number 3, why don't you take a look at it and see if you can write down those 2 fractions. Okay, so 1, 2, 3, 4, 5, 6. Oh gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 1, 2, 3, 4, 5. And obviously this one's probably going to be 5, 2. Okay. So if I have the same numerator, the smaller denominator will be larger. There we go, and 5 is definitely closer to 6 than 5 is to 12. Okay, we'll just do 1 or 2 more. On this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 have a denominator of 10, and this one has the denominator of 8. 1/10 or 1/8. Well, again, same numerator, smaller denominator would be larger. So 1/10 is less than. Let's do one more and then we'll move on. So let's take a look at this one. Figure out your denominators. And then your numerators. If the numerators are the same, the smaller denominator will be larger. So 3/8 is smaller than 3/6. Okay, so just a recap real quick. If you have the same numerator and different denominators, the smaller denominator is going to be larger. If you have the same denominator and the numerators are different, the larger numerator is the larger one. And then if you have number lines, you just create yourself a number line depending on the denominator. You would break your number line up into that many pieces, put on your constants, and then, or your benchmarks, and plug them on. And then with your picture ones, you just want to shade in the pictures, and then you can make a comparison. Now, guys, after we've done all that, let me grab my marker here, we are going to take a look at, sorry if I'm making you dizzy, I gotta go down and get this paper. We're gonna look at that paper I told you guys that you should have handy, and that is the one that has all the different notes that kind of show you how to do all this stuff, and most of them have a couple of examples. Now, the one for comparing fractions does not. It has one example and it kind of walks you through it. So what we're going to be doing with comparing fractions for the most part is what's called cross multiplication. So here you have two fractions, 6/10 and 2/3, and these are the 3 steps that you need to do to complete the comparing. Because if you notice, these do not have the same numerators and they do not have the same denominators. We don't have a picture. Now you could draw one if you wanted to, or you could do a number line, but that might be a little challenging because they don't have the same denominators. So what would you divide it into? That would take a little more work. So what we're going to do is we're going to do cross multiplication, or you cross multiply. And how you do that, if you look here, you're going to take your first fraction and your second fraction. You're going to start with your denominator on the second fraction and go up to the numerator on the first fraction, and you're going to multiply those numbers. So 3 times 6, that equals 18. I put a little 18 up here in the corner. And then you start with your denominator on your first fraction and multiply it with the numerator on the second fraction. So 10 times 2, that equals 20. So now, instead of comparing the fractions, you're going to compare the 18 and the 20. Now that's a lot easier to compare. So 18 is less than 20. We all agree with that, I'm sure. So we can put in our sign that 18, with the sign less than 20. So therefore, 6/10 is also less than 2/3. So easy. I know you guys did this in 3rd grade too. So real simple. And if you kind of notice, this makes what looks like a multiplication sign. So it's just bottom to top, bottom to top. Make sure you put your answer above the top number. Stop there. Don't put it on the other side. So 3 times 6, 18. 10 times 2, 20. So what I'd like for us to do is I have a couple of problems here that I'd like for us to kind of look at, and I'm going to work them out here. So I'm going to put them on my board. I guess I wouldn't have to. I guess we could just do it right here on the paper. And we can think about some different things whenever we're doing this, okay? If they have the same numerator, or if they have the same denominator, you might know right away what to do. Well, most of these already have that, don't they? Well, let's just do a couple of these. So if I have 1/5 and 10/5, that sounds weird because that's an improper fraction, which we did talk about a little bit, but we'll talk more about that tomorrow. So if they're the same same denominator, the larger numerator will win. So it's going to be a less than sign. Okay, so same denominator, larger numerator. Same denominator, larger numerator. Same denominator, larger numerator. You know what? I'm done with that. Let's move on to something else. I will put some problems on my whiteboard, and we will use cross multiplication to solve them. Okay? So let's do 3/8 and compare it to 7/9. And I'm sorry with my left hand, kind of cross it over in front of the paper or the phone. Okay, so cross multiplication. Start with your bottom, go up, multiply with your 3. 9 times 3 is, 27. And then 8 times 7 is, 56. So which one's larger, 56 or 27? 56. So 3/8 is less than 7/9. All right, very good. Would probably been a good idea if I would have gotten an eraser. Okay, so let's try another one. Let's do 7/10 and compare that to 5/8. Oh, goodness, I must have 8. You know how I do that when I get a number stuck in my head. Okay, so we're going to go this way, and that's going to be 56. And we go that way, that's going to be 50. And 56 and 50, well, that one's pretty close. You know what's kind of cool about that is, when I was telling you, the closer the number is from the top to the bottom, well, these are both 3 away. So that means, I'm going to have to cross multiply to make sure I know that for sure. So anyway, 7/10 is greater than 5/8. Okay, let's try one more. And then I've got a paper here that I'd like for us to kind of take a look at. And so this is, let's do 3/4, and let's do 6/7. That's kind of a crazy one. So we'll look at this way. That's 21. Go that way. That's 24. And we can see that 3/4 is less than 6/7. All right. Very good. Now, what I'd like to take a look at just for a second are some of these questions. This question right here, which statement is true? So we've got the statement 1/2 is greater than 4/5. That's A. We've got B, 2/6 is equal to 1/3. Or C, 1/4 is greater than 3/12. Which statement is true? Let's take a look at the board. So if I had to pick one of these, what I would want to do is I would want to cross multiply each of them, and then I could figure out which one is true. So this equals 5 and this equals 8. So 5 is actually less than 8, so that cannot be true. This is 6 and that is 6. I think we have a winner. Let's go down here. This is 12 and this is 12. So those are the same number, but it doesn't have an equal sign. So B would have been the correct answer. Why don't you guys take a look at this one and see if you can solve it? I'm going to write it down on my board while you're working. Okay, so which of these is true? So if we cross multiply, let's go ahead and cross multiply the first one. So we cross multiply, that's 12, and that's 6. So 12 is actually greater than 6, so that cannot be it. Oh. So this one's 2/3. So this would be 8, and that would be 3. So 8 less than 3. No. Hope this one works. So that's 10. And that is 15. That doesn't seem right either. 10 is greater than 3. So, my goodness, it looks like this one is wrong, wrong, wrong. Unless I had something written down incorrectly. I don't believe so. Oh, yes, I did. Caught my own mistake. There we go. That one's true. You're back there. You're probably at home going, Mrs. Borman, that's not right. Okay, so 20 is greater than 15, so it would have been the last one. All right, very good. Now, let's take a look at number 5. I want you to read it. Maybe think about what you're going to do. Okay, so what we're going to do is we're going to take the two fractions and we're going to compare them because they want to know which one ate more. So we need the bigger fraction. So we're going to end up comparing 1/2 and 3/7. So that's what we're doing. We've got 1/2 and 3/7. So 7 times 1 is 7 and 2 times 3 is 6. So we take a look at that and we see that 7 is larger than 6, so 1/2 is greater than 6. Take a look at the next one. Okay, sorry if I made you dizzy. So we're going to be comparing 3/4 and 5/8, and we want to see who ran the shorter distance, which means we want the smaller fraction. Okay, so we're going to multiply here, which is 24, and we multiply here, which is 20, and we can see that 24 is larger than 20, so the answer would be 5/8. 5/8. So who ran the shorter amount of time? His brother. Right here. His brother ran 5/8. So it would be his brother. And over here it would have been Joe. All right. So basically, guys, what we're kind of focusing on is comparing fractions, and we are going to be using cross multiplication to do that. Okay, or number lines, or pictures. Now, I do want to show you real quick because I know this is on Study Island. If you would do Study Island, I think what we're going to do with that is anyone that does these Study Island lessons, because we do have to kind of get through them pretty quickly, I'm just going to be giving you bonus points for completing them. But let's say we have the fractions. We'll go with 2/3. And we're going to compare it with, let's go with 1/6. Now, we can do cross multiplication, or we can find which number or what number is a multiple of both of these numbers. And you remember multiples are skip counting. Well, if I skip count by 3s, 0, 3, 6. And if I skip count by 6s, then I would go 0, 6. So 6 is actually a common factor of both 3 and 6. So what I want to do is make them both have the denominator of 6. Well, since this one already has that, I just need to change this. Now, do you remember before we left, we did equivalent fractions? So if I want this to have a denominator of 6, I'm going to have to multiply this by 2 to get 6. And that means that has to be multiplied by 2, which that means that's 4. So now I can compare them because they have the same denominator. So now I can compare them, and I know if they have the same denominator, the larger numerator wins. So that's one way to do it. That's finding a common denominator. Now, what if, let's just try a different one. What if we have something more like this? Let's do 2/3 and 3/5. Well, remember, another way to do common or finding equivalent fractions is just thinking about a number that both 3 and 5 have in common, but you can multiply them. But if I would skip count, I would go 0, 3, 6, 9, 12, 15. Well, 0, 5, 10, 15. Both of these are the first number that they both have in common is 15. So I'm going to change both of these to have a denominator of 15. So to get a 15 on 2/3, I'm going to put a 15 on the bottom. And I would times that by 5 and times that by 5, so that would be 10. And if I want this one, to have a denominator of 15, I'm going to times it by 3 and times it by 3. That'll be 9. So now I'm actually going to be comparing 10/15 to 9/15. And since they have the same denominator, the bigger numerator wins. Now, that's going to be more of where you're headed in the 5th grade, okay? So we are doing cross multiplication. But there you go, you have it. There are some of these questions on Study Island. If you end up doing Study Island, you might see where you have to multiply by the same number to get a new fraction before you can compare. But that's another way you can do it. You can find the denominator that they both can have in common, which in this case would be a 15. Okay. So we've been on here for 36 minutes, and there was one other thing I kind of wanted to show you, which was comparing fractions on a number line. So I'm going to kind of move over here just real quick, and I'm going to shorten this up a little bit. I'm just going to do these examples. I had some things to show you, but I think I'm just going to show you right here, and this is it. So when you're ordering fractions, you're also going to be thinking about these constants, the 0, the half, and the 1. And you're going to be creating a number line most often to put these numbers in order, or it will help you. So you think about the benchmarks, 0, half, and 1, and you can create a little number line that have them on there. And then if you look at our first example, I've got 3 fractions, and we're going to put them on the number line, and that's going to help us figure out the order of them, like which is the smallest to the biggest, or sometimes they might ask us to do biggest to smallest, greatest to least. When I look at these, I want to look, do any of them equal 0? That means they would have a 0 over the denominator. No. Do any of them equal 1? Sorry about that. Do any of them equal 1? No, because that means they would have the same numerator and the same denominator. Do any of them equal a half? The answer to that would be yes. 5 is half of 10. Anytime your fractional or your numerator is half of the denominator, it equals half. So I'm going to put 5/10 right there, okay? Then I'm going to look at 3/8 and 4/6. Now, so what I have to think about is half. 8. What's half of 8? Half of 8 is 4. Anything that's less than 4 is going to go somewhere between 0 and a half, right? Because it's less than half. So we'll just put it on here. 3/8 will go on this side. And then if I have 4/6, what's half of 6? That's 3. Anything that's greater than 3 will go on the other side, or if it's less than 3 would go on the 0 to half side. So this is actually over here, so this would be 4/6. So now they're in order. 3/8, then 5/10, then 4/6. So 3/8 is the smallest, 5/10 is in the middle, 4/6 is the largest fraction. Now you're probably thinking, how did you do that again? Let me just move you down here for just a second. So think about half. Think about a half. And any fraction that the top number is half of the bottom number, so like 4 and 8, that's half. You'd put it right in the middle, okay? But anything that's less than that, like 3/8, 2/8, 1/8, that's going to be less than a half. So it would go in between this section. And then your other fractions are going to be like 5/8, 6/8, 7/8. Those are all greater than a half. So any of those would fall on between the half and the whole mark. So you can just kind of plug them in. We don't really have to have them evenly distributed. We're just trying to find out if they're less than half or greater than half at this point. Okay, so let's take a look at the, really needed an eraser. Let's take a look at the next example. Let me erase this also. Okay. And let's think about it, or are the fractions greater, less, or equal to a half? So we got 7/10. If I think of 10, what's half of 10? That's 5. 7's greater than that. So I'm going to put 7/10 on this side. 0/5. Well, that equals 0 because it has a 0 at the top. 6/6. Same on top and bottom, so that equals 1. So that's going to go there. 2/8. Well, half of 8 is 4. 2 is smaller than that. 2/8. So there they are in order. 0/5, 2/8, 7/10, and 6/6. Okay, this is our last one, and I promise we're going to stop for today, and then you're going to be doing a little bit on Google Classroom. Okay, so the first thing I want to do when I'm going to try to put fractions in order is I want to create myself just a real quick little number line, and I'm going to put my constants on there. 0, 1/2, 1 whole. Okay, I'm going to look at my fractions, and we'll see if any of them equal 0, 1/2, or 1 whole. So 4/9, 3/4, 7/14. 7/14. 7 is half of 14. So 7/14. I'm done with that one. Got it where it needs to be. Okay, 4/9. Tricky because 9's not an even number. So half of 9 is actually 4.5. Anything less than 4.5 would be less. Anything greater than 4.5 would be greater than a half. So 4 is less than 4.5, right? So that's going to go over here somewhere, 4/9. Then we have 3/4. Half of 4 is 2. So that means it's over here somewhere. Okay, so we got that one done, that one done. 1/8. Well, half of 8 is 4, so that's over here somewhere. Okay, and then 7/8. Again, half of 8 is 4, so that's over here. Now, wait a minute. I don't know for sure, but these are really in the right order. All I've done is try to put them in a spot like this is less, this is greater. So since I have two fractions over here, I have to compare. I have to compare them. So I actually am going to compare 4/9 and 1/8. So this is 32 and this is 9. Wow, so this has to be the smaller fraction. So I'm going to put 1/8 as the first one. That's the smallest one. Then it's going to be 4/9. Okay, then 7/14 isn't going to change because it's the half. Then I have to compare these two. That's 24 and that's 28. So those are actually in the right order. 3/4 and 7/8. So there are my fractions in order from least to greatest. Now, if you need to listen to that again, you can, because I'm not going to repeat all that. All right? So you can back up the video if you want to watch me sort through that again, okay? So on the next step, what I'd like for you guys to do is to log on to your Google Classroom, and I'm going to have about 10 problems, and I'd like for you to complete those 10 problems and submit it, because it's going to be on Google Forms, and you will be able to write onto the form and submit it. Okay? If anything changes between the time I leave here and I go home and put the Google form on, I will email you and let you know that that has changed. But that's the plan. We're going to do a Google form of you filling in the answers, and I'll probably have a couple of problems from each of the things I just showed you how to do. Okay, well, you guys have a great evening, a great day, and I will be back tomorrow. Hopefully we won't take as much time, and we'll be working on some other fraction stuff. Okay, bye-bye.